Could we fly to the stars already in this century? Let's think of warp drive. What is the Alcubierre bubble and how it will help humanity escape from the solar system? Some brilliant ideas come as an epiphany into scientists in different ways. An apple fell on Newton's head and he came up with the law of universal gravitation. Archimedes sat in a bath and then runs naked around the city shouting Eureka. After all, he had just created the law of Archimedes. Mexican theoretical physicist Miguel Alcubierre was struck by a revolutionary idea in the field of physics while watching Star Trek on TV. The plot of the movie is quite simple. The crew of the Starship Enterprise flies from planet to planet along the way, performing feats in scientific discoveries, meeting with various alien creatures. Miguel was interested in the way the Enterprise moved from star to star. He compressed space in front of him so the starship did not fly to the stars, but the stars themselves approached the spaceship. Imagine there is a cup of coffee on the table covered with a tablecloth. You can reach out and take it, or you can move the tablecloth along with the coffee. You don't reach for the cup, but the cup approaches you. Roughly the same thing happens with space in sci-fi series. The idea seemed very interesting to the Mexican physicist, and for fun he decided to try to calculate the possibility of creating such an engine. Surprisingly, the space-bending machine shown in Star Trek turned out to be a valid solution to Einstein's equations. That is, it is theoretically possible to create such an engine. A starship equipped with an Alcubierre engine must be surrounded by a bubble of curved space, a kind of hollow bubble of matter and energy. Then the cup moves closer to you. If we discard all complex calculations behind the spacecraft, the space swells up, and in front, on the contrary, it contracts. This rather interesting concept was of great interest to specialists from NASA, in particular Dr. Harold White, who significantly revised Alcubierre's original message, bringing it slightly closer to practical implementation. A topic that implicitly follows from the possibility of creating an Alcubierre lens white bubble can be roughly called metric nuclear power. The fact is that the stability of atomic nuclei and heavy elementary particles, first of all protons and neutrons, as well as the potential barriers to nuclear transformations, depend very significantly on the metric, hence on the local property of the space-time, or what is the same, on the intensity and gradient of the gravitational field. Depending on the local metric, nuclear reactions can go in different directions and with different probabilities. To some extent, this is analogous to the change in chemical equilibrium in the gas phase known as the Le Chatelier-Brown principle, although the analogy is rather distant. In nuclear physics proper, the dependence of transformations of elementary parts on the metric is illustrated by the Chandrasekhar gravitational limit. If this limit is exceeded, during the compression of the star, the process of fusion of electrons and protons into neutrons takes place in it. A neutron star is formed. It's neutrons that turn out to be the most stable under these conditions, although it's in the usual unperturbed metric, hence where there is no such high gravity, the neutron is unstable and undergoes beta decay into a proton and an electron. Even more sensitive to the metric are atomic nuclei with the insignificant margin of stability. As noted above, the conditional boundaries of the Alcubierre bubble represent a certain feature of the local metric, and it's very likely that nuclear processes in it will proceed significantly differently than in ordinary space with a slight gravitational curvature. Unlike the idea of the ship flying in a bubble, the idea of nuclear reactions in an area of the bubble boundaries does not require a significant size of the bubble and a significant time of its existence relative to an external observer. Everything can happen in a very small volume and very quickly. This kind of metric nuclear power may not only be easier to achieve, but also today more relevant than ultra-fast interstellar travel. It may very well be that with the development of technology and the advent of quantum computers, which, as we are promised, are just around the corner, the first flight to the stars, even though it seems surreal to us, will happen already in this century. So this is by Soul Ask. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box.